Hello, my name is Chendur Jayavelu. I'm an incoming junior in high school, and today we're going to be looking at question 37 of the April 2021 ACT Math section. So let's get to it. Okay, question 37. Rectangle JKLM is shown below. The given side are in feet. Okay, they're in feet. Okay, what is the cosine of angle KJL? Okay, pause the video once you've sort of figured it out, then hit playback again. Okay, so we need to figure out, okay, they've given us an angle, so angle KJL. We need to figure out what that specific angle is. And that angle is right here. I'm going to mark it in blue, right? So we need to find the cosine of that angle. And a good thing to point out is this is a rectangle, right? So a rectangle means the corners are 90 degrees. 90 degrees. So you can use put a 90 degree over there and 90 degree over there. And why specifically over here is I see two different triangles right here. I see this triangle and I see that triangle right there. And I don't want to put a 90 degree where the triangles are created. That side interferes with that angle. So I'm just going to deal with the triangles that they've given me. Okay. So now we need to find the cosine. So there's a short little trick to understand cosine. Remember, cosine is a trig ratio. And basically, all trig ratios are composed of opposites, opposites, my bad, opposites, adjacent, and hypotenuses. Hypotenuses. Okay, so basically, this is with respect to an angle. So basically, a side could be opposite to an angle. So for example, 7 is opposite to this angle, directly opposite. So we would call it an opposite, right? Similarly, we have 9, which is directly adjacent, right? Directly adjacent to that angle, our KJL. And the hypotenuse is very special to right triangles. It's the longest side of a right triangle. And it's basically opposite the right angle. So this is the hypotenuse right here of this particular triangle, regardless of what angle we're looking at, right? And we can use these trig ratios for right triangles, and we're given right triangles. So in order to remember these trig ratios, you should remember SO, CA, TOA, where this S stands for sine, C stands for cosine, and T stands for tangent. And basically, you can put even a slash in between the OH, so it's O over H, A over H, and O over A. And that represents either its opposite, adjacent, or hypotenuse. So sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, sweet. So we need to figure out the cosine of JKL, right? So the cosine of KJL. And that's going to be our adjacent side, which is directly next to it, but it's not the hypotenuse. So what's next to it? It's 9 over the hypotenuse. We do not have the hypotenuse over here. So what do we do, you may ask? Well, if you go back to geometry, right, and you remember right triangles, you can figure out the hypotenuse given the other two sides with the Pythagorean theorem. Basically, for the Pythagorean theorem, all you need to do is a squared plus b squared equals c squared, right? And c is the hypotenuse, right? My bad. You can see hypotenuse right there. So what we can do is we can take the square root of both sides. So c, the hypotenuse, I'm actually going to call it hypotenuse, it's going to be equal to the square root of the quantity a squared plus b squared. So then a and b represents the legs of the right triangle. So in this case, the legs of our triangle are 7 and 9. So it's going to be 7 squared plus 9 squared. And what basically the hypotenuse goes to the square root of 49 plus 81, which is the square root of 130. So our hypotenuse is 1 over the square root of 130. That means the hypotenuse of this triangle, we can apply it to our SOHCAHTOA right here. Cosine adjacent over hypotenuse. Adjacent is 9, which means our hypotenuse is the square root of 130. So that is the cosine of angle KJL, which means the answer is D. So that's question 37 for you. Thanks for watching. Hopefully you'll stick around for question number 38. Until next time, I'll see you again later. Thank you. Bye.